All right, ladies and gentlemen, we're looking at Chapter 3, Section 1, Constant Rate of Change Notes. Relationships that have straight line graphs are called linear. Relationships we can see the word line right inside that word linear. So it just stands for graphs, relationships that make a straight line. The rate of change between any 2 points in a linear relationship is the same. So any 2 points, that relationship stays the same or constant. Fancy your word for stays the same. Therefore, a linear relationship has a constant rate of change. Now that means that the relationship stays the same throughout. So we're going to take a look at example 1. So in this example, we're looking at the balance in a bank account after several transactions are shown. This is an input-output table. Your input, when you see that, is on the left. That's your X value. Your output is your Y value. And transaction just means like you go to the bank and you do something. So a transaction is something you're doing at the bank. So we are looking at the balance, and after 3 transactions, they have $170. And then after 6 transactions, which would be 3 more, so that's plus 3, what you look at happens at the numbers on the balance money is that's down 30. And then again, if we look at transaction again, it's 6 to 9, so that's plus 3, and the balance goes from 140 to 110, again down 30. Back to the X values, 9 to 12 is again plus 3, 110 to 80 is down 30. So when we're looking at whether or not a relationship is linear, we are looking at the rate of change, and that is the change in Y over change in X. Again, change in Y on top over the change in X on the bottom. So the change in the Y value is that down 30 each time, and we're looking at the change in X being up 3 each time, or a positive 3. So that results in a rate of change that is staying the same. Now we could reduce it to negative 10 over 3, which is down $10 for every 1. Down $10 for every 1 transaction. But the key there is that the transactions rate is the same. And so this relationship is linear because the rate stayed the same each time. So you're going to try the got it's on 172, and then you're going to enter those answers onto Edpuzzle. All right, so looking at example 2, we have a relationship if there's proportional linear relationship. So we're looking for linear, but this time we're also looking for proportional. So let's look for linear first. Again, that's that same idea that we are looking for a constant rate of change. Now this input-output table is set up a little bit differently. We have our X or input right here, and that's coming first. And then we have our Y or our output coming second on the bottom. So we have our X's on the top, Y's on the bottom, instead of a left and right. But we're still looking for the rate of change. Now remember, the rate of change is Y over X. So we're looking at what change is occurring through each of the inputs, and that is going up 5 each time. And then we look for the change on the outputs, and that is going up 9, 41 to 50, up 9, 50 to 59, up 9, and 59 to 68, again, up 9. So looking at that, that's going by up 9 each time. So that is a constant rate of change of 9 over 5. Switching them around because it's the change in Y over change in X. So we have a constant rate of change of 9/5. So since the rate of change is constant, this is a linear relationship. That graph will form a line. Now, proportional, we look at something else. We look at the ratios between the y and the x. So you can see the y degrees Fahrenheit over the x degrees Celsius, and we're looking at that relationship. So we're looking at 41 over 5, y over x, and we find the value for that. So you do 41 divided by 5, and you get 8.2. Then you do 50 divided by 10, that's the next set of points, and that gives you 5. Then you pick another set, we've got 59 divided by 15, and that gives you about 3.9. And the key there is that these are not the same. Since the ratios are different, or not equal, the relationship between the degrees Fahrenheit and degrees Celsius is not proportional. If it would have been equal, it would be proportional. Now there's another way to tell that. When you graph the points on a coordinate plane, we can see that the graph points all appear to fall in a straight line. So the relationship is linear. And then when we look at the line connecting the points and where it goes, the starting point is at 30-ish, and it does not pass through the origin. So the line connecting the points does not, or doesn't, pass through the origin. The origin is right there on the corner. The origin is 0, 0. So the relationship is not proportional. So what we gather from that is that if the ratios are equal, and we can tell if the graph passes through the origin, then a relationship is called proportional. I'd like you to try page 174. Got it? Letter C.